Hello all. Our next chapter is election algorithm, and this chapter you can refer from Distributed Operating System by PK Sinha book. So election algorithm in distributed system is mainly required to elect coordinator process. So coordinator process is a process which will have certain responsibility. That means it can be to manage something or to make some kind of decisions and so on. So, in the later chapters, we are going to discuss many of the algorithms wherein we require a coordinator process, a process who should be having some responsibility, who should be doing some decision making task. So, in a distributed system, as we all know, it is nothing but a collection of processors. So, there will be n number of processors. So, at any point in time, one of the processor is required to be coordinator, let us say for some job. In that case, we will be using the election algorithm. So using election algorithm, among n number of processors, one of them will be elected to become the coordinator. Now if that coordinator processor fails, then again election algorithm will be executed to find another processor or another successive coordinator processor. So the election algorithm will be executed in distributed system uh, in two reasons. One is when the distributed system are getting initialized, that is in the initial phase. If we need a coordinator process, then we need to execute the election algorithm in the distributed system. And secondly, when election algorithm will be executed is when a coordinator process fails. So if a coordinator processor fails, then if some other processor has detected that the coordinator is not working or not responding, then in the distributed system, again the election algorithm will have to be executed. So basically here you need to remember that the election algorithm in the distributed system is required to elect the coordinator process so as to do some task. So there are various types of election algorithm, but in this chapter we will be discussing about two types of election algorithm. One is Bully algorithm, the other one is ring algorithm. So they are differentiated based on the organization of processor or the topology of processor in the distributed system, and based on whether the processor knows the ID of other processes or not. So based on these two reasons, we can differentiate these two algorithms, that is Bully algorithm and ring algorithm. We will be discussing in this chapter. So now here, why we need coordinator in the distributed system, as I have already discussed about it. We need coordinator basically to make some decisions, to do some task for achieving some goal. For example, centralized mutual exclusion algorithm. Let us say in the previous chapter we had discussed about mutual exclusion algorithm wherein there was no coordinator. Suppose if we do not have coordinator, then we need to use token based mutual exclusion algorithm or non token based mutual exclusion algorithm. But if we want to make it simple and have a coordinator to decide on which process should be allowed to enter in the critical section at any point in time, in that case we also need to have the election algorithm. So that should be executed in order to elect the coordinator process. So what happens in centralized mutual exclusion algorithm is one of the process will be elected to become the coordinator, and it is going to decide on which other process is allowed to enter in the critical section at any point in time. So this way, in the later chapter also we are going to see many algorithm which requires coordinator process, and how the coordinator process will be determined is it will be determined by executing the election algorithm. Now this we have already discussed when the election algorithm will be executed is that one is during the initialization of the distributed system. Secondly, when the coordinator process fails. Now, how the election algorithm will be executed, or which other process, okay, which active process is going to execute the election algorithm, it depends on the type of election algorithm that we are using. Now, usually what happens is that whenever any other process finds that the coordinator is not responding, for example, let us say a process X in the distributed system sent a request message to the coordinator and it did not receive any response message from the coordinator. Now, that can be any process, a random process. Now, any process, whoever has found out that the coordinator process is not currently working, is allowed to execute the election algorithms. So, any process can execute the election algorithm, can initiate the election algorithm to determine the coordinator, to determine the next coordinator process, since the current is not working. Now, with this one, it may so happen that simultaneously more than one processes may have initiated the election algorithm because all of them did not get the response from the coordinator. Now, the election algorithms should be in such a way that when simultaneous election algorithm gets executed, all the election algorithm, no matter how many election algorithm are getting initiated, all of them should be electing the same coordinator. It should never happen that more than one coordinator is getting elected in the distributed system. So, to make it simple, the election algorithm, what it does is that it assigns ID to all the processes in the distributed system, and every election algorithm, it elect that process to be the next coordinator having the highest ID. So, the coordinator will be that process in a distributed system which is currently having the highest ID. Let us say there are 5 processes, P1, P2, P3, P4 and P5, and let us say P5 is the process having the highest ID value, or you can say highest priority to become the coordinator. Now, during the initialization of the distributed system, P5 will be elected to become the coordinator. Now, if P5 fails and if some other process out of P1, P2, P3 and P4 detected that the P5 is not responding, then any of those process will be initiating the election algorithm, or there can be more than one process initiating the election algorithm. But all of them should come up with the same final decision regarding who should be the next process. Now, next process for the coordinator will be P4 because P5 is not working, so P4 is the next successor for coordinator. So, all the election algorithm should be electing same process, that is P4, to be the next coordinator process. So, next we are going to see the first election algorithm, that is Bully algorithm. And Bully algorithm has a requirement, and it requires all process to know the ID, the ID that exists in the distributed system. Okay, they need not know whether the process with that ID is currently working or it is not working, it has failed, or you can say active or inactive. Okay, so active means functioning properly and inactive means it's not working, some failure has occurred. So, in case of Bully algorithm, it is not necessary that every process should know about other process whether they are functioning or not, but the requirement here is every process should know the range of ID. Every process should know that how many processes are there in the distributed system and their ID. So, let us say we have say 5 processes in my distributed system, P1, P2, P3, P4 and P5. The requirement of Bully algorithm says that every process should know the ID, okay, set of ID that exists, that is there in that distributed system. So how this Bully algorithm works is, as I said, all the election algorithm elect the same process as the coordinator process, which is nothing but the process having the highest ID. So let us say in this scenario it will be the P5 which will be the current coordinator. Now P5 will be the coordinator, and for some reason if P5 fails, then it will not be able to do the job of the coordinator. Now what happens is that how the Bully election algorithm works is that, suppose if some process detected that the coordinator is not working, for example let us say P2 detected that the coordinator is not working because it had sent a request message for which it did not get any response from P5. So this P2 will be initiating the election algorithm, wherein it will be sending a message to all other processes having higher priority than itself. So that message is called election message. So the first message that will be used here is called election message. Now what this election message is doing is that P2, since it discovered that the current coordinator is not working, so it is trying to find out whether there is any other higher priority process which is currently active in the distributed system or not. So if P5 is not working, if P5 is not working, then P2 is trying to find out whether P3 or P4 is working or not. So it is sending the election message to P3 and P4. Now since in this scenario P3 and P4 both are working, they are fine, so they will be sending another message. So they will be sending reply to P2 saying that they are alive and they are functioning, and this return message is called alive message. Now if P2 receives alive message from any other processes, because P2 had sent election message to only those processes having higher priority than itself, let us say ID is equal to priority. So that means if it receives alive message from any of the other processes, it means in this distributed system there exists another process with higher priority than P2 itself. So now that means P2 will understand that it cannot be the next coordinator, there is some other process who will have to further continue the election process and find out who is the highest priority process currently alive in the distributed system. So P2 has received the alive message in response to the election message which it had sent to P3 and P4. Now P3, after getting the election message, it will understand that the current coordinator is not working in the distributed system. So P3 will again send the election message to all other processes having higher priority than itself. Similarly, P3 do not know whether P5 is actually working or not. So again P4 will also send election message to all other processes having higher priority than itself. Now in this scenario P3 will be receiving the reply message from P4. P3 will be receiving the reply message from P4 because P4 is alive. So if it receives any of the at least one or alive message, then the election process will not be continued by that particular process, because that particular process knows that there is some other process currently in the distributed system which is alive with higher priority than itself. Now when P4 had sent the election message to P5, it will not receive the alive message. So there will be some timeline until which P4 will wait to receive the alive message, and if it does not receive alive message from any of the processes having higher priority than itself, then it will declare itself as the next coordinator, and it will be sending the coordinator message to all other processes. Obviously, those processes will be the processes having lower priority than itself. So that means in the Bully election algorithm, 3 type of messages will be used. One is election, alive, and the coordinator. And how this Bully election algorithm work is, whenever a process detect that the coordinator is not working, it will be sending election message to all other processes having higher priority than itself. Now, if there is any other process having higher priority than itself which is alive, they will be sending alive message. So if a process receives alive message from at least one alive message also, if it receives, it means it itself cannot be the next coordinator, so it will stop there itself. So it is the responsibility of now higher priority process to continue the election. Now the higher priority process, after sending alive message, again they will be sending election message to all other processes having higher priority than itself, because in the distributed system a process will not be knowing about the status, working status of other processes, so they will have to ask, get the response, and then they will get to know the alive status of the other processes. So this way, if a process does not receive any alive message, then it will declare itself as the coordinator, and it will be sending the coordinator message to all other processes with the lower priority, obviously. So this is how the coordinator gets selected in case of Bully election algorithm. So the Bully election algorithm requires every process to know the ID of all other processes. Next algorithm is ring election algorithm. Now ring election algorithm will be used if the processes are connected in form of ring in the distributed system. So if the topology is a ring topology, then ring election algorithm can be used. Now here also at any point in time, it will be the highest priority or process having highest ID will be the coordinator process. So for example, in this case it will be the P5. Now suppose if P5 has failed, somehow P5 is not working, that means P1 is communicating directly with P4. So this ring can be unidirectional or bidirectional. Now let us say P5 is not working, and because of which P1 is directly sending to P4 for their job. Now to, let us say for some task, for example, P2 needed some response from the coordinator, some decision from the coordinator. So P2 will be sending the request to P5, but since P5 is not working, P2 will not be receiving any response from P5. So that means P2 will understand that the current coordinator in the distributed system has failed. So for that, as we had discussed previously, that whenever a process finds that the current coordinator is not working, any process, it can be any process, will be initiating the election algorithm. And it may so happen that more than one process may initiate the election algorithm simultaneously, but the requirement is no matter how many election algorithms are getting executed, they all should be electing the same process for the coordinator. Now in this case, since P2 found out P5 is not working, it will be initiating the election process, wherein it will be sending the election message in the ring. Okay, so let us say the communication is P2 to P3, P3 to P4, P4 to P1, and let us say P1 to P2. So P2 will be creating a election message, and what will be present in the election message is the ID. Okay, so whichever process will be getting this election message, they will keep on inserting their own ID. So when P2 will be initializing the election message, it will be storing the ID and it will be forwarding to P3. Similarly, when P3 receives the election message from P2, ID2 will be present in the election message, wherein P3 will be appending its own ID, that is 3, this will be sent to P4. Now P4 will again append its ID, that is 4, and it will be sent to P1. Similarly, P1 will also do the same, that is 2, 3, 4 is already there, and P1 will be appending its ID, that is 1, and it will be sent to P2. Now when a process receives its own election message back, so how it will identify that it has received its own election message back is from the ID that is present in the first location. So when P2 will be receiving its election message back, so it is going to identify this. So it is going to identify this from the ID that is present in the first location, that is in this location, right? So 2 is the ID of P2, and in the first location the ID that is present is also 2. Now what P2 will do is it will just go through or scan this election message, and it will select the highest number, that is the priority or ID of the process. Now P2, after scanning, it finds that it is P4 which is having the highest ID. So P2 will be creating a coordinator message. In the coordinator message, it is going to insert the ID of the next highest processes which is currently active in the distributed system. So that is 4. Now P4 should be the next coordinator. So now the coordinator message will also be sent via the same path. So P2 will be sending the coordinator message to P3. P3 will record that the coordinator has changed. Now it has become 4. Similarly, P3 will also forward to P4. P4, after getting the coordinator message, it will understand that it has to be the next coordinator. So P4 now will start acting as a coordinator process. Along with that, it will forward that coordinator process in the ring. So P1 will also get to know about the coordinator process, and hence finally P2 will get back its own coordinator message, which it will simply discard. So this is how with one coordinator message, the next coordinator process could also identify that it should be acting as a coordinator, and all other processes also got the information about the new coordinator process. So here also, if more than one process initiate the election algorithm simultaneously, that will not create any problem. Like for example, here more than one process is initiating the election algorithm since the process 7 has crashed, but there is no problem because ultimately if more than one process initiates the election algorithm, they are going to select the same process to be the next coordinator, even though the number of messages that will be communicated in the distributed system will be more. So this is about the election algorithm.